Hey everyone, welcome to our project. Our project is Shrub, which is a new kind of hedge. In other words, we're a peer-to-peer insurance marketplace. In this project, we decided to use a Raspberry Pi as a sensor to detect earthquakes, and then use that earthquake connected to smart contracts to manage a peer-to-peer insurance contract for earthquake insurance. So in traditional earthquake insurance, the insurance company needs a large pool of reserves in order to pay out assets. If there's an earthquake, it affects everyone at once, and they have to pay out everyone at once. And so it's very expensive for them to maintain the reserves. What happens is they sell their risk to reinsurance companies, whose sole job it is to insure the insurer companies. These reinsurance companies actually sometimes package their risk and sell to investors in the form of catastrophic bonds. In which case the bonds pay out if there is an earthquake to the reinsurance companies. That system is bloated and inefficient, and all of those costs are passed on to consumers. What Shrub does is we create a peer-to-peer catastrophic insurance marketplace. In this case, we have a peer-to-peer contract for an earthquake. So whenever there is an earthquake detected above a certain magnitude, it pays out one side of the contract. The other side of the contract is paid out if the contract expires without an earthquake. In this video, we're going to overview our tech stack and UI. We're going to show you our sensor in action detecting an earthquake in a Lego village. And then we're going to walk you through the UI for the contract. We're really excited about this project because it has the opportunity to make catastrophic insurance cheaper for everyone. Only 13% of homes in California right now have earthquake insurance, mostly due to its expenses. Across the world, there are other catastrophic events that people are unable to find insurance for, and this marketplace would allow us to spin up contracts for these various events and allow them to be funded by the community. For our tech stack, we're using a Raspberry Pi that's communicating with the Lambda function to update a state in DynamoDB. A Chainlink oracle is also connecting to this Lambda function in order to read that state and pass that on via an HTTP request to our smart contract. Users can interact with our contract through React. We're using Brownie as our testing and deployment framework. Our contract is a stateful contract. In the pre-trigger version of our contract, this is before an insurance event triggers, the main user interaction for the contract is through the buy tokens function. In this function, the user exchanges DAI for a pair of our contract tokens. These tokens are special because each one will pay out in case of a certain event. In this case, if there's an earthquake, this token A, will pay out. And if there's no earthquake by the time that the contract is expired, this token B, will pay out. The user is free to transfer these tokens however they want. And in the case of someone who wants earthquake insurance, they can sell their no earthquake tokens, or the B tokens, to people who are interested in the other side of the investment. The standard rate of payout is 1 DAI for every redeemable token, and tokens are only redeemable if that event happens. As you can see, this means that there will always be 1 DAI for every 1 token, because one of these pairs of tokens will always be worthless. But there's a better way to do this. Normal insurance companies invest what's called the float, the amount of money that's stored in their reserves, in order to make money. Because our insurance is peer-to-peer, we don't need to make the money, but we can make the protocol even better by making use of this float to actually invest. For that, we're using 88 MPH. An admin of the manager contract can routinely make deposits as the balances on the contract grow. These deposits to 88 MPH earn interest in the form of fixed interest rate bonds at set time periods. The admin can every week submit the balance to 88 MPH and then collect the interest. The next state of our contract is a post-trigger state. In this case, let's just say that the earthquake event happened. The user can now exchange their earthquake tokens for DAI, plus a portion of the interest pool that was achieved using 88 MPH. This portion of the interest is calculated based on the overall number of tokens being redeemed. As you can see, the B token, if there was no earthquake, is now worthless. This is the city of Shrubtopia. It's named after the landmark shrub in the middle of town square. But Shrubtopia has a problem. There are often a lot of earthquakes. Alice is a business owner in Shrubtopia. In order to combat the earthquake, she bought earthquake insurance. Shrubtopia has an earthquake detection system, which is actually a Raspberry Pi connected to an accelerometer. When the system detects an earthquake, the LED will turn on, indicating that the API was called to change the state in our DynamoDB database. As you can see, the LED is off, but the earthquake station is primed and ready to detect an earthquake. Now let's see what happens during an earthquake. Wow, that's a lot of damage, but you can see our LED is on, which means that the earthquake station sent a signal to the cloud. Alice's business is completely damaged, but luckily she has Shrub insurance. Okay, so this is our deployment function. We basically deploy the two versions of our token, right? Deploy our stablecoin, which is our ERC20 token as well. We deploy our test 88 MPH. This is like a dummy 88 MPH contract that we can just test on our networks and test and deploy, but it has the same functionality as their mainnet contract. This is our manager function, which we're deploying with those other contracts in the constructor. And yeah, then we have a transfer power function, which is basically allowing the manager to have kind of God powers on these two ERC20 tokens. And then we're transferring some test tokens around. So let's go ahead and try that out. Okay, as you can see, we've had our contracts deployed. So now let's go ahead and jump over to our UI and interact with them. So this is the Shrub Marketplace UI. There are two main functions. You can purchase your token, and they're purchased in pairs. And then you have your balances of your current A token balance, your DAI balance. So right now, as you can see, we have 0 balance, but we have our test DAI already. And then after something happens with the state, you can actually redeem the tokens. So let's go ahead and purchase some tokens. Let's try purchasing 1,000 tokens. Or you know what, let's do 10,000. So we can go ahead and approve that with our MetaMask. And then we need to give the network time to do its thing, but we should be able to refresh the page and then have our tokens be ready. So off camera, it took a little while to update on the network, but I was able to, so I put in another transaction. But as you can see, both those transactions went through. Here we have our updated DAI balance, our token balance, and if we go to Etherscan, once again, we can see, you can see a few of my panicked submissions. Some of those will probably come through. But the point is that we have our 2000 A token and 2000 B token balance, and it was subtracted from our DAI balance. Now, what we can do is we can actually, from our admin contract, we can have the manager actually send these this DAI that's now in our manager contract to 88 MPH. So 88 MPH, as you know, is an awesome protocol. They basically offer fixed APY bonds. And so what we do is we send them, and how this would work in real life is we'd probably send these contracts. Manager would probably be on a cron job just to send it every week to do a 7-day contract. And okay, so let's jump back over to our code, and then we can actually test that out. Okay, so from using our admin contract, we're going to load that. And then we're going to load our manager contract as well. And we're going to go ahead and deposit 2,000 of our tokens. And then we're going to withdraw it. And so our manager contract, normally this would take place over weeks or months. But we've coded up our 88 MPH test contract to just send us back the tokens with interest immediately. Okay, so those contracts have successfully went through on RinkB, and so our manager contract should have received those tokens with interest now. Let's go back over to our UI, and now we can click and actually redeem our tokens. And so what should happen is that we'll actually check our Chainlink node, and then the Chainlink node will hit our Lambda function, which checks the state. The state has been set to 1. We can actually go there now. Yeah, so our state is 1 right now. It was deployed with state 0. But as soon as the redeem button is hit, that's when we'll actually go through our Chainlink Oracle and then our own node that we're hosting on RinkB to hit this. It will hit our Lambda function first, which is this one. I can just show you the code. Basically, it's just a normal HTTP post. So not too important, but here it is. Okay, so let's go ahead and hit redeem, and it will redeem all of our tokens into whichever one is actually valuable. So let's do that. And we will approve with MetaMask. So here in our Chainlink console, you can see that we have just created that job. Right now, it's still waiting to run, but we'll jump right back as soon as it's done. Okay, so that's actually almost done. So let's actually jump over to the manager contract, and then we can see what's actually going on here. All right, let's see, contracts manager. So the user is calling this redeem function, which is requesting. This is the Oracle that we set up, connected to our job ID, and then we're storing that redeem request, who actually sent it. So on the fulfill, we're actually calculating if the state is changing, which only happens once in these contracts. We're doing an early withdrawal from 88 MPH, and then we're calculating the total supply and token price. So we're calculating the actual interest earned, and then we create this interest multiplier. And then when we go to actually pay out interest, we multiply that interest. So this redeem execute is paying out the interest. If state 1, that means tokens A pays out. Then for every token A that you have, it'll pay out the amount that you have in tokens times that interest multiplier, which is the interest that was earned through 88 MPH. So let's jump over and see if this job was run. Okay, that looks good. And now let's jump over to our React app and see if our balances have changed. Awesome, so our state is equal to 1. You can see our token balances are now 0. And you can see we got the 2,000 back from, actually the A token is the only one that mattered. But we also got the 200 in interest, which was our share of interest from the 88 MPH. So that's Shrub. We really appreciate everyone tuning into our project, and we're really excited to move this project forward in the future and actually create an insurance marketplace on mainnet. Thanks for watching.